In this lesson, you'll learn to determine solutions of equations in two variables. Now, if you're given an equation, a solution to the equation would be something that you can plug in for both the variables, and you will get out a true statement. So for example, if you're given here 4 ordered pairs, remember an ordered pair consists of an x and a y component, right? The first value is x, second part is y. So what I can do is to determine if this point is a solution. What I can do is I can plug in a 1 for x, and then the -2, plug it in for y, and see what we get. So if I plug a 1 in for x, I have 3 times 1, and then plus the y, so plus the -2, that equals 1. So if you solve this, you get 3, and then plus -2, which gives you 1. So you have 1 equals 1. Notice that is a true statement. So therefore, the ordered pair 1, -2 would be a solution. And you could do that same process for any of these other 3 points. So let's try for 1, -4. So for this point, the first number is your x value, second number is your y value. So if I were to plug in a 1 in for x and a -4 in for y, let's see what we get. So if we put a 3 times a 1 instead of 3 times x, and then if we have plus a -4 instead of plus y, we'd have 3 plus -4, which gives me -1. So -1 would equal 1. That is not a true statement, so therefore the point 1, -4 would not be a solution. Let's try for the other two. So for 1, 0, 1 is your x value, 0 is your y value. Plug a 1 in for x. So we have 3 times 1, and then plug a 0 in for y. So we have plus 0 equals 1. This would be 3 plus 0, which is 3. So 3 equals 1. That is not a true statement, so therefore that would not be a solution. And then for the last one, 0, 1, plug a 0 in for x, a 1 in for y, and we get 3 times 0 plus 1 equals 1. So this would be 0 plus 1, which is 1. So 1 equals 1. That is a true statement, so therefore the point 0, 1 would be a solution. Now for the next part of the lesson, you will be given only one number to plug in, and you are to find the other number. So for example, here you have an equation, and let's say you're given the domain. By the way, this is a term to know. The word domain means your values for x. So your values for x are given to you as -1, 0, and 1. So looking at the first one, if you plug a -1 in for x, the question is to solve given -1 for x. So if x is -1, the question is, what is y going to be? So if I plug a -1 in for x, instead of 9 times x, I have 9 times -1. So I have 9 times -1 plus 2y equals 15. 9 times -1 is -9. And now I can solve this for y. So to get rid of the -9, I can add 9 to both sides. And now I have 2y equals 15 plus 9, which is 24. Divide both sides by 2. And we have y equals 24 over 2, which is going to be 12. So the solution when x is -1 would be y would equal 12. I can write this as an ordered pair, by the way, because an ordered pair has an x and a y value, x and a y component. So x is -1, and then y would be 12. So this would be your ordered pair. And then we repeat for the other values for x. So plug a 0 in for x, then a 1 in for x. So if we plug a 0 in for x, what we have is 9 times 0 plus 2y equals 15. 9 times 0 is just 0. So what we have is 2y equals 15. And then solve for y, just divide both sides by 2. And we have y equals 15 over 2, which is going to be 7.5. And you can write this as an ordered pair where x is 0, and then we solve for y was 15 over 2. And it does not matter if you write it as a improper fraction or a decimal. Whichever is easier for you, you can do that way. But if you do use a fraction, please make sure that you reduce your fractions completely. And then for the last value for x, plug a 1 in. So plug a 1 in for x. So instead of 9 times x, we have 9 times 1. So 9 times 1 is 9. We can solve this for y by subtracting the 9 over. And so we have 15 minus 9 is 6. So 2y equals 6. Divide both sides by 2. And we have y equals 6 over 2, which is going to be 3. So my solution for that one would be when x is 1, y is 3, which would be the order pair 1, 3. And now the question is, what if we're given the values for y? And that's what we call the range. So another term to know, range are your values for y. Meaning, this is what we're going to plug in for y, and in this case, we're going to see what we get for x. So this is the same type of problem that we just did, except we're working backwards. Instead of plugging numbers in for x, we're plugging numbers now in for y. So looking at the equation, we have 9x plus 2y equals 15. Each of these are different values for y. So negative 1, you plug in for y, and we see what we get for x. So negative 1 in for y, we have 9x plus 2 times negative 1 equals 15. 2 times negative 1 is negative 2. And then solve for x. So we can add 2 to both sides. We have 9x equals 15 plus 2, which is 17. And then solve for x by dividing both sides by 9. And that gives me x equals 17 over 9. So my solution would be x is 17 over 9, and then y, our y value is negative 1. So this would be your ordered pair, 17 ninths, comma, negative 1. And once again, we could write 17 over 9 as a decimal if we prefer. And now we do the same thing with the 0, and then do the same thing with a 1. Plug a 0 in for y. We have 9x plus 2 times 0 equals 15. And then 2 times 0 is just 0. So we have 9x equals 15. And then solve for x by dividing both sides by 9. And we have x equals 15 over 9, which can reduce, and you get 5/3. So my solution for that one would be x is 5/3, y was 0. So that would be your ordered pair, 5/3, comma, 0. And then do the same thing now with the 1. So we're going to plug this 1 in for y. So we have 9x plus 2 times 1 equals 15. 2 times 1 is 2. And then solve for x. So we subtract 2 over. We have 9x equals 15 minus 2, which is 13. And then solve for x by dividing both sides by 9. And now we have x equals 13 over 9. So my solution for that part would be 13 over 9, comma, 1. And that is my solution. So to recap, what we do is just simply plug in the different values that are given to us and solve for the missing part and write your final answer as an ordered pair. And that concludes our lesson for today, and we will see you next time.